now we're going to discuss something called the normal contact force. Acha, what is this force? It's a force that acts acting at a right angle. I'm just making up a definition, so it might be not that uh, accurate, but I hope it makes sense. Force acting at a right angle opposite to the weight. So it's a force that acts at a right angle in the direction opposite to the weight. At the point of contact as well. At the point of contact. Okay. So let's say here's a particle which is touching the ground, making this the point of contact and this the weight, mg. So then the normal contact force would be acting perpendicular in the direction, opposite to the weight at the point of contact. So this is where it needs to be in the direction opposite to the weight. So the weight was downwards, this is going to be upwards, and it is formed at a right angle with the surface. So it makes a right angle with the surface. So it's a force acting at a right angle opposite to the weight at the point of contact. So that's the normal contact force. I'm calling it NCR. Okay, we also know that from Newton's third law that every action has an equal and opposite reaction. So this is an application of that if, let's say, you're standing on the ground, you're exerting some weight downwards, but you're not falling into the ground, although there's a force acting on you downwards, but you're not falling inside the ground because there's an opposite reaction. There's also a force that the ground is exerting on you, exactly in the opposite direction. So the two forces cancel each other out. That's why you're not falling into the ground. So let's say that now a particle is placed on a slope. So then this is the contact. And the normal contact force is normal to the surface of contact. So it's going to be in this direction now. Similarly, let's say there's a slope like this, a particle, here's the contact. So normal contact force would be in this direction. Achha, it's not necessarily opposite to the weight, because we'll see later when we do inclined surfaces that in such cases the weight is actually in this direction and the weight is in this direction. So it's not necessarily opposite to the weight. But if the weight is vertical, then yes, it's opposite to the weight. Otherwise, if the weight is inclined, it's not opposite to the weight, but we don't need to be bothered about that at this time. So you just need to know that normal contact force is going to make a 90-degree angle with the surface at the point of contact. Okay, so that's the basic concept of normal contact force, that wherever there's contact, there's weight, there's going to be an opposite reaction in the form of normal contact force. So as the particle exerts a force onto the surface exerts an opposite force in the opposite direction at a 90-degree angle. Okay. Let's say that there's a lift and there's a weighing machine on the lift. And you're standing on that weighing scale, which is showing your weight. What happens when, let's say the weight of this person is 50 kgs. So weight is 50 kgs when the lift is at rest. Lift is at rest. So that's the first case. A person got onto the lift, which was at rest. There was a weighing scale. He got on it and he noticed that his weight was 50 kgs. However, when the lift starts moving upwards, that is, it accelerates, lift accelerates upwards. So then the person will notice that his weight increases. Let's say it now becomes 55 kgs. So the observation is that the weight increases. Okay, so the lift was originally at rest, then it then it started to move upwards, it started to accelerate, and the person noticed that the weighing scale is now showing more weight. Then the third case would be that the lift starts to slow down. So the lift now decelerates. Lift decelerates, still going upwards. So now he'll notice that the weight becomes smaller than the original weight. Let's say it now becomes 45 kg. So his observation is that weight decreases. And the fourth scenario is that lift stops. So now the weight scales again shows a weight of 50 kgs. So what's happening here? How come his weight is changing as the lift goes upwards? Actually, it's not the weight that is changing, it's the normal contact force that's changing. And the weighing scale actually measures the normal contact force, not the actual weight. So let's state that down. Weigh scale measures the normal contact force and not the weight. They're the same thing. There's exactly the same if the lift is at rest. But when the lift is not at rest, it's not going to be the same as the weight. Its value will change. We'll see why. So the weighing scale actually reads the normal contact force and not the actual weight. So what's happening in case one? How come the normal contact force and the weight have the same value? Okay, so in case one, lift is at rest. So acceleration is 0 since there's no change in speed. So there's going to be a downward force of weight and there's going to be an upward force in the opposite direction, which is the normal contact force. So forward force could be the normal contact force minus backward force could be the weight equals MA, which is 0. So that's why normal contact force and the weight have the same value. That's why the weighing scale was showing the actual weight. So weighing scale shows correct weight. Okay. I'm going to send you a new link and we're going to conclude mechanics part in 5 more minutes. So in the second case, what happens is that the lift grabs some speed and so it is accelerating and it's going upwards. So now let's look at the person and the weighing scale. Now it's going upwards and it's accelerating. Acceleration means its A will have some positive value. So now again, the downward force is mg, the actual weight. The upward force is the normal contact force, the reading that the weighing scale actually shows, and acceleration is positive. So I'm going to use the formula forward force. Now the forward force should be the upward force. So it's going to be the normal contact force. So normal contact force is the forward force minus the backward force, which is mg, equals ma. So the normal contact force is the weight mg plus the value ma. So it becomes bigger than the weight. This was the weight. And the normal contact force is not just the weight plus a positive value, mass times acceleration. Mass is positive and acceleration is always also positive because the lift is accelerating. So that's why now the weighing scale shows a weight which is shows a value that's actually greater than the weight. So weighing scale shows value greater than the actual weight. Case 3 is that the lift now begins to slow down. So it decelerates. So now the acceleration is going to be negative because the lift is slowing down. So again, it's going upward still. So the motion is upward. The guy is still standing on the weigh scale. And the downward motion, the downward force is still mg. The upward force is still normal contact force. So forward force, normal contact force, minus backward force, the weight, equals mass times acceleration. So normal contact, and now this has a negative value. This is negative. So I'm going to write minus ma. This is actually minus ma because acceleration is negative. So normal contact force equals mg minus ma. So that's why the weighing scale shows you a value that's actually smaller than the weight, because this is the weight, but you have to subtract ma from it, the mass and the deceleration. So that's why the weighing scale was showing a weight, that a value that was less than the actual weight, because you also have to subtract ma from it. Hence, weighing scale shows a value less than the actual weight. And lastly, case 4 is when the lift stops. So it's the same as case 1, where the lift was also at rest. So that's why the weighing scale shows the correct weight, because now the normal contact force has a value equals to the weight because acceleration is 0. So this is the theory behind why a weighing scale shows different values when the lift moves upwards. Because the weighing scale actually measures the normal contact force and not the weight. And the normal contact force changes in every case. It's something else when the lift is at rest. It's something else when the lift accelerates or when it decelerates. So according to that, the weighing scale shows a different value. Sometimes it's exactly the same as weight. Sometimes it's a value bigger than the actual weight. And sometimes it's a value smaller than the actual weight. Okay. I think we should do 1 or 2 questions on it as well, so that we don't have to discuss it all over again tomorrow. कर लें 1-2 questions इस पर, normal contact force पे. या चलो कल करा दूंगी, इतना पॉजिटिव रिस्पॉन्स आया तो ठीक है, कल करा दूंगी. ठीक है, आई एम गोइंग टू stop recording this and we're going to discuss the. All right, so we're doing questions related to or involving normal contact force today. Okay, the pilot of a hot air balloon has a mass of, this is 85 kgs. Okay, so the mass is 85 kgs, and as the balloon leaves the ground, the normal contact force on the pilot from the floor of the balloon immediately increases to 901 newtons. So as the hot air balloon leaves the ground, there is a hot air balloon. Okay. So as it leaves the ground, the normal contact force immediately increases to 901. So what direction should I draw the normal contact force in? Pointing downwards, pointing upwards.
Pointing upwards.
Yes. The balloon is going upwards. Weight is going to be downwards. Normal contact force is perpendicular to the weight in the opposite direction or perpendicular to the contact. So it's going to be at 90° to the contact. Okay, so it should be upwards, normal contact force. Okay, and this is 901 newtons. And remain at this value for the first stage of the ascent. Calculate the acceleration of the balloon in this stage of the motion. Okay, so what should be the downward force? The upward force is the normal contact force. What should be the downward force? The weight होगा ना in downwards direction. So weight is mg, always mass times gravitational acceleration, which is 10 in math, not 9.8. So this should be 850 newtons. Okay, now the question is asking for acceleration. How do we find the acceleration? Can you guys hear me?
Yesterday,
Hmm.
yes.
Yes, Alia?
Yesterday we did the case where it was like the normal contact force would be equals to mg plus ma, so we could just use that.
Normal contact force is not always equals to mg plus
It's
ma.
not always, but in this situation it would work
Why would it work in this situation?
because you have the
You always start with Newton's second law because that is what tells you whether it's addition or subtraction or whatever, because it depends on the direction of motion. Yesterday, all the cases we did were also upward motions, but we had different answers for many upward motion cases, right? They were all upward motion. So is this one. So you always start the equation using Newton's second law, which is forward force minus backward force equals ma. What is going to be the forward force here? Yes, Azhar, what's going to be the forward force? Azhar, are you there? Aisha, can you hear me?
yes, yes.
What's going to be the upward force?
Plus 901 Newton.
I meant forward force, not the upward force. Forward force is the force in the direction of motion. So which force is in the direction of motion? 901 is in the direction of motion. 850 is against the direction of motion, equals to m, which is 85 times a. To find a, you subtract and divide. So it should be 901 minus 850 divided by 85, 0.6. अजहर आप इधर नहीं हो? Where is Azhar?
मैम मैं हूँ, मेरे नेट
जी
मैम नेट का इश्यू आ रहा है अभी
अच्छा.
मेरा।
So you had to use forward minus backward force equals to ma. Forward force is the force in direction of motion, which in this case is going to be 901 newtons, which is the normal contact force. Backward force is the force against the direction of motion, which in this case will be the weight. 850 newtons equals ma. It was a pretty straightforward question. ये होना चाहिए था आप लोगों से. Question 8. A man stands on a bathroom scale placed on the floor of a stationary lift. The reading is 90 kgs. Okay. So man is standing in a lift on a weighing scale. And it says that when it's stationary, it reads 90 kg. Then it says while the lift is moving upwards, he finds that the reading is now 86 kgs. So the reading has decreased in value. Account for this change and describe the motion of the lift at this time. So what is happening in the lift because of which the weight becomes, or the scale shows a value less than the actual weight? कल ये मैंने notes में लिखवाए थे काफी cases. So what was the case when,
It's decelerating.
yes, the lift is decelerating? That's why the normal contact force becomes less than the actual weight. So describe the motion of the lift at this time. So we saw it is decelerating as discussed yesterday. Okay, so now let's show that in an equation. So lift, person standing on the weighing machine. Okay, lift is going upwards, but now it's decelerating. That means its speed is decreasing. So what should be the forward force? What should be the backward force here? Forward force is the force in direction of motion. So what is the force being applied here? It's the
90
90 के
Normal contact force.
900
900 तो नीचे होगा ना, यहाँ weight is 900. ऊपर है normal contact force. So the weight is pointing downwards, normal contact force is pointing upwards. So forward force minus backward force equals ma. In this case, which force is the forward force? Lift ऊपर जा रही है, तो forward force फिर,
नॉर्मल कॉन्टैक्ट
हाँ जी.
तो
So
ऊपर की
contact मैंने NCR लिखा हुआ है, it's NCF. So normal contact force minus weight equals ma, but it's negative here. And the normal contact force will be weight minus ma. That's why it decreases in value. Hence, weigh scale shows a value smaller than the weight. Because the weighing scale actually measures the normal contact force. Okay. Next question. A man of mass capital M kgs and his son of mass small m kgs are standing in a lift. Okay. So a man and a child they're both standing in a lift. This mass of the man is m kgs. So what should be the weight of the man? दाऊद आप बता
And
Yes, 10m. Okay, 10 capital M. And the weight of the boy is going to be 10 small m. M times G. G is 10 meters per second square. Okay. When the lift is accelerating upwards with a magnitude of 1 meters per second, the magnitude of normal contact force exerted on the man by the lift floor is 800 newtons, 880 newtons. So on the man, the normal contact force is 880 newtons in this direction. Okay, so this is case one, when the lift is accelerating. So let's form an equation using Newton's second law for this case. What should it be? Show the direction of the lift using double arrows. So it's going upwards as stated in the question. What should be the equation? दाऊद आप ये बता सकते हो क्या होगी इक्वेशन?
मैम मैम ये होगा
अजहर आप बता सकते हो? दाऊद बेटे ध्यान दो, साथ साथ पढ़ो। जी अजहर, क्या इक्वेशन होगी?
मैम forward force
G
minus backward force.
G equals ma. So what's the forward force on the man? केस वन में खाली मैन की बात हो रही है, सब कुछ फिगर पे ड्रॉ हुआ वही अप्लाई करना आना चाहिए।
मैम 880 newtons
जी आगे
minus backward force 10 mm
जी
or
equals
mass equals m into a.
A given a 1. So forward force,
Mm.
which is 880, minus backward force, which is 10 capital M equals MA. 880 minus 10 capital M equals M times acceleration is 1. Give me the value of M from here. What are we getting?
80.
Okay, 80 kilograms. Okay. When the lift is moving with a constant speed, the combined magnitude of normal contact force exerted on the man and the boy by the lift floor is 1000 newtons. When the lift is moving with a constant speed, so let's call it case 2. Speed is constant. What does that mean, Daud?
Ma'am, acceleration 0.
J. So forward force will be equals to backward force. So when the lift is moving with a constant speed, the combined magnitude of the normal contact force exerted on the man and the boy by the lift is 1000 newtons. Okay. So now on both of them together, the normal contact force is 1000 newtons. So I'm going to consider this as one person because the normal contact force is exerted on both of them. So this upward force is going to be 1000 newtons acting on both of them. So what should be the downward force here? If the normal contact force is acting on both of them, then the lower force needs to be the weight of
Is
both
their
these.
weights combined?
Yes, both the weights combined.
800 plus.
Sorry,
मैम कुछ नहीं.
it would be
800
800
को
plus 10m because m is now 80. So it's going to be 800 plus 10m. Okay. So let's apply the formula. Forward force is 1000 minus backward force is in brackets. I'm going to write 800 plus 10m equals ma. What should be the m here? M is again the combined mass. So combined mass is 10m. M भी बल्कि हमें पता है 80 plus m times acceleration, but that's 0. So it's going to be forward force equals to backward force. Give me the value of small m from here.
Twenty kg.
Yes, 20 kgs. Find the values of capital M and small m. We've already done that. Okay, next question. A spring balance hangs from the roof of a lift. I don't exactly know what is a spring balance, but probably पता नहीं क्या होता यूं करके कोई चीज. It measures the weight as well. Okay, a spring balance hangs from the roof of a lift. A case of mass m kg is hung from the spring balance by a string. A gauge string आ गई. Okay. And a mass is hanging from it. Okay, so the spring balance is then something else. When the lift is accelerating upwards, with magnitude a meters per second, the reading on the balance is 12.5. When the lift is moving downwards with an acceleration of a, the reading is 9 kg. Find the values of m and a. Okay. Okay, so let me just redraw this. So there is some machine which measures the weight or weight, the normal contact force of the object it's carrying. So it's carrying a mass M. So it says that when the lift is accelerating upwards, so let's call it case 1, it's accelerating and it's going upwards. Okay. The reading on the balance is 12.5 kgs. Okay. So the reading is 12.5. And when the lift is moving downwards, case 2, the acceleration is A and the reading is 9 kgs. Find the values of M and A. Okay. Now what is this reading? ये reading क्या चीज है? The reading is the normal contact force, okay, not the actual weight. The weight is going to be 10 m. Okay, so in case 1, the lift is going upwards. So the upward force on the lift is the normal contact force. And this is the normal contact force. But the normal contact force needs to be in Newton, and this is in kgs, so multiply it with 10. So normal contact force here, as discussed earlier, that a weighing scale actually gives you the measure of the normal contact force. So it should be 12.5 into 10, which is 125 newtons. So upward force is 125 newtons. 125 newtons. Okay, downward force is the weight, which is going to be 10 m. Okay, and we form an equation using these two. So since it's going upwards, it should be 125 minus 10 m. The m is supposed to be small according to the question. 10 m equals to ma. Okay, so that's the first equation. Okay, let's form a second equation. Now the lift is going downwards. Normal contact force now is going to be 90 kgs from 90 newtons. So the upward force is 90 newtons. The downward force is the mass of the object, which is going to be 10 m again. Now the lift is going downwards. So forward force would be 10 m. Minus backward force would be 90 newtons equals m times acceleration. Okay. Now you have to find the value of small m and value of small a. You can do that by first equating these two. Equate the left-hand side of both the equations because their right-hand side is the same. So 25 minus 10 m equals 10 m minus 90. So m comes out to be what?
Mami, 125 newtons in
Oh, sorry, 125. सही है. चलो दाऊद जाग रहा है. Happy to know.
10.75.
and 0.75.
ठीक है, so this is the mass, it has to be in kgs. Now find acceleration. Use either one of the equations with the value of m just found.
मैम 1.623 आ रहा है.
ठीक है. Acceleration should be 1.63 meters per second square. I hope the others also got the same answer. Okay. That's all from normal contact force. I think we should conclude mechanics lesson here. Or tomorrow we're going to talk about. Sorry, I accidentally stopped sharing. Acha, I'm supposed to share the other screen. So tomorrow we'll talk about angular forces. ठीक है, तो normal contact force इधर खत्म हो गया.